Now that most people have their Tiny Tapeout 5 boards, we did a Bringup party stream, which was just private to the people who were on the Tiny Tapeout 5 shuttle. And the aim was to help people test their design and show some designs working on the stream. So in this stream, you're going to see my RGB mixer, an ALU design, Flappy Bird VGA, Linux booting, which is pretty amazing. Looking a bit more at that ALU, Uri's Game of Life, Gerrit's ring oscillator, some more VGA experiments, a loopback measurement using a high-speed scope, and playing Super Mario theme tune on an ASIC. So if that sounds interesting, you can use the shortcuts in the description below to jump to the one that sounds most interesting, and make sure you get your design in for Tiny Tapeout 8 if you want to join a Tiny Tapeout Bringup party. My aim really here is to support everybody on the call who wants to test or try their design, and also invite any of you if you want to demonstrate your design on the stream. It's just a private stream for now, but I'm recording it. That would be great. And yeah, demo some of the designs we've got, and we want to submit test results using the Commander app because we're tracking that stuff better now. And anyone who tests and reports their designs, if you don't already have the tested Tapeout role on the Discord, we can give you that, and also a free tile for Tiny Tapeout 8 if you want to try something on Tiny Tapeout 8. So maybe I will share my screen. Well, does anyone have something they want to show? Does anyone want to demonstrate something? Yes, Devin. So maybe I'll go first then, because I've got some designs on here. So I'll go with the classic RGB mixer. So then with the Commander app, the new button, Devin, is this one. Uri has put it in yellow, so we can't miss it. So I've already set up my RGB mixer and set the clock speed. So that's already running. And then I've got my AD3 connected up here. And I can see I've got 2 PWM signals coming out. And maybe I can try to toggle the frequency using the Commander app. So I think the other thing we've got here is the pin out. So encoder pin A and B is on input 0 and 1. So if I toggle this, I think I can see this frequency getting bigger here. Let's try the other one as well. That looks good. And then let's see how fast we can go. Let me just get Pat on the stage. Hey, Pat.
Hey! You can use the measurement thing. If you move if you look at the window there, yeah, on the top right, see that that horizontal and vertical measurement. One of them is a pulse. The third one next to the 1, 2, 3, 4, next to the magnifying glass. That.
Oh yeah.
Okay, so the one before the 1, 2, 3, 4.
Okay. Oh yeah.
So you can just put it somewhere, just click it, and then leave it there, and then toggle your stuff, and you should.
Can I do 2 at once?
I don't think so.
Okay. Whoa.
Yeah, that's a weird one for like timing of vehicles.
Okay. Yeah. So let's go back here then. So we've got 7.3 milliseconds there. Okay, cool. Yeah, all right. So let's see if that. Let's see how fast we can run this then. So let's go to a megahertz. Toggle, 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 toggle. That looks good. Check this top one as well. I love the AD3. It's so easy to like use, drag the screen around and this kind of stuff.
Yeah. And if you want to keep an eye on something permanently, you just use the measurements thing and just add some monitor for whatever feature. You can look at both channels that way.
Okay, 10 megahertz. Cool. 25 meg. I guess this little noise here is the coming from the other pulse there. And let's go all the way to 50. Did that work? Look the same as 10.
Yeah.
Oh no.
Oh no.
There we go.
But we weren't at 10. We were at 25, weren't we?
Yeah. Oh, okay. Let's try that again then. Looks good. Looks good.
Okay, yeah. It was 6 micro and then it went to 3. But that noise doesn't seem to be the other signal. It's not at the right place, is it?
Yeah, I think so, yeah.
Oh, yeah, it is. Okay.
Okay, and then let's just check the output channel 3 as well. That's the blue one. And that is going to be controlled by... There we go. Okay, so cool. All 3 channels checked up to 50. So then I can click this button, report results, and say yes. Tested all 3 channels up to 50 meg. Submit feedback. And then you get like a little listing here. Because it's my project, I get the crown. And then I think if we go back to here, the state all the designs, you then can see here on the right if they've been tested or not. So where's my RGB mix? So yeah, so there's one test there. So what we want to do is try and get through all of the designs, all the people here, and get a tested. Whether the design works or fails doesn't matter. The important thing is to test it. So let's see. Did anyone say? Okay. All right. Let's see. Daniel's getting stuff. Gerrit has got some small things. Matthias, you tested it. But if you want to show the design of my students a 4-bit ALU, they'd be very happy. Number 200. Okay, so let's do that then. And sorry, Tisha, you've not received yours yet. Have you checked the tracking? Do you know where it is at least? And Daniel Robinson's ready. So, okay, let's. Why don't we invite Daniel onto the stream then? Not quite sure how to actually do that. This is the link. Can I just post that in here? We can only let a few people join at once. I think it's like limited to 10 people. So Daniel, do you want to try clicking that link? And then I should get you at the bottom. I can add you to the stream. And Pat, you've got some stuff to share later as well, don't you? What are you going to show?
I'm set up for the analog, the ring oscillator, and the A to D or D to A converter.
Cool.
The analog project that was secretly stuck on TTO5, basically.
From Harold, yeah. And yeah, maybe people have already seen it. I did a demo of that, but Pat has automated done a nice automation with the AD3, so that's something new to share.
Yeah, the idea is that I'm going to, well, I'm finished documenting it, but I'm going to publish all the thing, and it'll be an example of going through
Yeah.
using the AV3. So, and it's pretty cool because I learned a few things using it, and the scripting engine is a lot of fun to use. I gotta
Yeah.
say.
JavaScript better than Python, though, unfortunately.
Yeah, but I hardly even noticed. It has some nice autocomplete. You do your setup in one tab, and whatever you set up appears in the scripting engine. It's pretty smooth.
Cool. Okay. Daniel, did you? There we go. And Logic Destroyer has joined. Logic Destroyer. Daniel, did you try the link? Did it work? Just wait for you for a bit. Maybe I'll try to check this. Which was the other one? Number 200. Let me try that one then.
Yeah, the ALU. How's it work?
Yeah, we'll find out. See how well documented it is.
Nice.
Let me stop that. So, number 200. Can I change this one? Oh, that's cool.
Yeah, it is cool.
Nice one, Uri. Okay, so then we've got the pinout here. 2 adders, multiplier, comparator, and a barrel shifter. Inputs and outputs. And we need to provide inputs. We need to provide an opcode. Yeah. Okay, so let's select that. I don't know if we need to run it at any frequency. And then let's check the docs. No clock required.
So it's combinatorial.
First 4 inputs, first operand, set loss, second operand, computation results, bidirectional are used for the opcode, figure above. Okay, maybe we're missing a figure then to know which opcode is which. Resources. Ooh, this is nice.
Yes.
Top marks. Okay, ripple carry adder. That's 0 opcode, so that's cool. So we should be able to check this just with the digits then. So with interact, I can set. All right, so pressing this bit 0, I get the top segment lit. So that's bit. So that's the 0 bit, and that is the second bit. So that's added to zeros, 3 and 4. Okay, and then these ones repeat because they're not being added together. And then if I add 1 and 1, I get 2. Good. If I add 2 and 2, I get 4. 4 and 4, I get 8. And does it carry over? Yeah.
How? Oh, with the dot? No.
With them all together, I'm getting how to read this? 1, 2, 4. So I've got bits 1, 2, 1, 2, 3, and 4 all lit, and bit 0 is not lit. And I have to probably do a truth table to figure that out.
But no, it's just maximum -1, right?
Yeah. Okay, so let's come back to that in a bit because I can see Daniel Robinson is ready. Hi, Daniel.
Hi.
Welcome to the Bringup party.
Thanks. Can you hear me?
Yeah, I can hear you good. Yeah.
Cool. Okay, so this is my design. It's Flappy VGA. It's a very simple version of Flappy Bird with the VGA output, and I guess I'll just demonstrate it. I've got the score printing over on my computer. The design itself outputs the score just with the 8 bits from the bidirectional. They're set as outputs.
Okay.
So I've got the RP2040, just reading those and sending them over serial to my
Oh,
computer.
nice.
But yeah, I've got a button hooked up down here. So that's what I'm going to be pressing. And,
Yes.
I will demonstrate it. So the goal is just to not hit the pipes.
Yes.
And you can see the score is going up each time I go through a pipe.
Oh, cool.
So that's you pressing, just going bump, 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 bump.
Yep.
Well, you've definitely practiced this game a bit before.
Yes. I'd be dead already.
Yeah.
And I'll demonstrate dying. So yeah, just stops and resets. And then if I start going again, my score will start ticking up back from 1 again.
Back from 0, okay.
So, and you can see it goes back to counting up. Yeah, actually, let me step back a bit. So you can see I'm pressing the button each time.
Yeah.
Wow.
I tried playing it with the Commander app, and it was really difficult doing it with a toggle switch.
Yeah, the toggles don't work so well for it. It'd be kind of cool to add an option to do buttons like where you just press it once and it acts kind of like this in the Commander app. Probably pretty doable.
Yeah. Okay. So I'm gonna keep a list of ideas. That one actually might already be an idea.
There's an issue for a pulse generation. I don't know if that was just a clock or an input.
One other thing, it'd be good to be able to set it if that does get added, to be able to set it to be either active high or active low.
Yeah.
Because different designs will need either active high or active low.
Oh yeah, this has been opened
For the SDK.
No, it's on the Commander.
Oh well, it's on both. This is
Yeah.
Uri has an issue on the MicroPython firmware too.
Okay. Yeah, Anton opened it on the.
o'clock.
I'll post a link to the issue in the chat. In the chat. Yeah. So Daniel, how does it feel to? Is this your first ASIC?
Yeah. Yep.
How does it feel? How does it?
It's good. It's nice. I'm happy with it. I'm glad it's working for sure. I wasn't 100% sure it would.
Yeah.
But it's 100%.
I kept it pretty simple to try to make sure it would work.
Huh.
Have you already submitted your test results?
No, I haven't done that yet. I saw that though. I can open up Commander on here actually.
Yeah, you want to submit it now.
Let's see.
Then we can press the air horn button. Yes, and how did you like the demo board?
It's really nice. Yeah, it seems really well done.
And the Commander app.
Commander app also. Yep.
Any feedback you want to give to Pat, given that he's the board designer and on the call?
Not really. It's pretty well set up. Okay, here we go. I'm just loading up my design from Commander. VGA. Set the clock. And yep, it's going good. So then, yeah, I can just report the results here. Is that how that works?
Nice.
Thanks
very much. Great. Okay. Anything else you want to say?
Not really. This is a really cool project. I'm planning to submit something for Tiny Tapeout 8 as well. Try to do that competition.
Great. Well, you can use your bonus free tile on that. And do you have your cutout on Discord? Do you already have the tested Tapeout role?
Yeah, I already have it.
Okay, cool. I don't need to add
congrats.
it. Send you
It's
a
awesome
tile.
that it just works.
Yeah, it is nice that it just works.
Yeah, congratulations. Thanks for sharing your design on the stream.
Thanks. Yep, thanks for having me.
Okay, so we also had Hirosh. Do you want to come back on? You were on earlier. And the other person who said could also join was Matthias, if you want to join.
There's no way with the commander to actually read the outputs, because you were listing when we were looking at the ALU. It never tells us.
You could read them with the REPL, I guess.
Right. Okay.
Yeah. But I'm just looking. So we decided that we were going to re-record this Linux excerpt as a separate interview. So I've removed the talk that we've done here and just edited out. But you can see here the board is connected to a memory. The Linux needs quite a lot of external memory, and because it's using an SPI interface, that is a limit on its speed. And here the kernel is booting, and we can see it loading Linux. And then we get to the end, and the author showed a few commands as well. So really incredible to see micro Linux running on a tiny Tapeout ASIC, and stay tuned for a more in-depth interview all about that process.
It's not my design actually, so my students made that. But I think they are not online here, I guess. So I'm the only representative from the group now. But yeah, it's an ALU, a 4-bit ALU, nothing special. And I also told them, let's do something combinatorial first before we do something that can be clocked, just to make sure that everything works out. And yeah, this morning we tested it, and it perfectly worked.
And did you report your results?
So no, not yet reported. So we will tomorrow, since we have only 4 bits, and 2 inputs, we have just 8 bits as input. So we just test all combinations.
All combinations. Okay.
Yeah, it's rather easy, right? So
yeah, will you do that with writing a little Python script, or are you just going to do that?
Yeah, so that was my question in the Discord.
You were asking the question about how do you connect. Yeah.
So how's the best way to do that? And I think I write a Python script and just copy and paste it in the commander, and that's it, right? So
yeah, cool.
But I think I will use this design for teaching, because we have several different implementations of adders and multipliers. So we have a ripple carry adder, which has a long critical path. Okay, with 4 bits, it's not that long, right? But we also have a carry look ahead adder, which should be probably twice as fast. And my question is, maybe since you have a nice scope there, if you could maybe measure the delay, basically, or is that not possible?
Yeah, let's try it.
So that was my question. I don't know how your IOs are buffered, or if they are clocked or whatever.
So, no, they're not clocked. They go through the mux, but we already know how fast the mux is. So we can select your design.
Yeah. So I was interacting with the REPL actually, with the design so far.
Okay.
And
so should I put the should I get the scope on which output pins? I guess
maybe to see the highest effect, it would be probably on the carry bit, I guess. So let me.
Oh, that one would have the longest delay, is what you're saying?
Yes, exactly, because that would be the critical path. So let me just think about it. So before you added 15 plus 15, so that would be 30, right? And 30, we would have 16 plus 4, right? So we...
that would be 20.
No, sorry, yeah, we need more. So what is it?
Where's the carry come out?
Exactly. So the I can't read it. So it should be the 5th bit that you should check. would make sense, because if we have two 4-bit numbers, the carry can be only on the 5th.
Right.
So this one you should maybe put in the scope then, the S4, right?
Okay, S4. So that's
out 4.
Yeah, it's always because this is 0 index, so 0, 1, 2, 3, 4. So that's going to be the first pin on the second row of the P mod. Okay, that's in there.
And we're just doing opcode 000. So we can't trigger on the opcode. We need to trigger on one of the input bits.
Yeah. So
then that line should go, at the moment that is low. Sorry, that's let me turn off this. And we're expecting it to go high once all of these are turned on. Oh, it went high then.
Yeah, it will go up earlier already.
Yeah.
So the question is, what is now the critical pattern? So maybe no, it's not going up here. Probably have to press 2 twice. And maybe you also have to measure the input. Is that possible?
Yeah, you have to measure the input to trigger on it.
Yeah. So that's.
But which input? Like bit in 4?
Yeah, the one that we change probably.
Yeah.
But if we need to change 2 at the same time, so maybe change them. So when
he goes 0, 1, 2, 3, and then trips 4, the carry comes up, right? Is that good enough?
Yeah, that's probably enough, because so I'm not sure how because I did not use these buttons. I used the REPL to do it, but anyway, it should also work. So this would be the most significant bit for operator A, and the most significant bit of operator B would be the 7th, I guess. So if you toggle this, it also should change the output when you click on 7. Can you do it?
Mm-hmm.
It doesn't change it.
No.
Well, now everything is on except 7, right? So if the carry's high. That makes sense, doesn't it? It's 15 plus 8.
Yeah.
So that's 18 plus 5, 20 something. So
that's 7. It's 7. Right now it's 7 plus 15. Yeah. But why did it change when you then toggle the other bit, the 3? That's no, it's not. And
it's if you 4.
Which one you toggled before? Here?
I don't know why.
Is it moving? Oh, it's your trigger.
Yeah. Okay. Yeah. So, and I've got 2 things here. So the blue is input 3. So as I toggle that, we're also seeing the output toggle. So maybe we can just do. I don't think we're ready to do this yet, but we could.
I don't understand when it's green. Input 3 is the blue line and it goes low.
Are you asking me?
Yeah, I'm asking you.
The blue. I don't see any green, but the blue.
No,
is
I mean in the commander, it's green, so that means it's on, right?
On, yeah.
Yes.
Yeah.
And so now it's low. Doesn't make sense.
Now I understand it.
Yeah.
Now we have 7 plus 7.
I see what you're saying, yeah.
This is 7 plus 7. So maybe
yeah, but I mean
7 is 14. There we don't have the carry. So, and if you make now 7 plus 15, then we have the carry. So now you have to measure the time distance between your click. So you have to trigger on the bit 3 here. This is what you have to trigger. And then we have to see how long it takes that the result goes up. And
Yeah.
then we
So I
switch
need
to the other adder, and then we compare this. That would be very interesting.
So yeah.
How do I switch so that I'm triggering on the blue, Pat? I can't remember.
You want to trigger on the blue?
Yeah.
There's a look in options there above your channels. Hold on, I can't remember where the trigger is. It might be in rate and samples, like the time thing, but I'll check in my interface. Choop. Let's go.
I remember getting confused by this before.
Oh, source. It's at the top. It's next to your trigger, auto, normal, whatever. It's just the source.
Is it because my window is not big enough?
Yeah, that's it. There you go. See, source channel 1 here.
Yeah. Okay. So now I should be able to. What's this doing?
So you found it?
Yeah, he found it, but like I said, when you turn it on, it goes low. I think your probe is inverted. Look, if you just put the trigger on auto, you'll see when you turn it on, it goes under 0. See? It's going down. That's not good. Something is wrong. Your probe is flipped. But it doesn't really matter. You could just put your trigger point under it and it'll work.
Yeah, that's weird.
Yes. Doop.
Okay. And then we need to
zoom out.
Move that to the middle. And now we're finally getting close to making a measurement.
Okay, that's probably what I thought. So what is the time resolution of your scope here?
It's not very high, I'm afraid.
Okay, so maybe then I have to tomorrow at work I will use one which is pretty high. So it's 5 nanoseconds something.
It's 34.
Yeah, I thought 34, and it's about a 20 nanosecond round delay for just like a wire. So we're seeing like a 15 nanosecond delay with the ALU.
So, for just a wire, what do you mean?
That if you have the factory test loopback and we measure the latency there, it's about 20 nanoseconds.
Okay.
So it's 35 nanoseconds. Basically.
Yes.
Minus 20.
Minus that 20.
That's the baseline. So 15.
Okay. Yeah, so it's 15. So now it would be interesting if you now take the carry look ahead adder, which should be 2 times faster, if we can see there any effect.
Yeah, and I need to do that with the bidirectionals, don't I?
Exactly. So you have to set the bidirectionals to output, I guess, because we see that from the Raspberry Pi perspective. And then you have to set it to
1.
To
bit
1.
0 needs to be 1, yeah.
And then you get the other one.
So I do that here, do I?
Yeah. So you can go tt dot by, what is it, by dear direction or something. Hold on a second.
Idea mode.
Idea
Give me 2
mode.
seconds. Is that what it is? CT
No.
by dear. It's by dear mode, I guess. I guess you're right. Yes. Equals pins dot out times 8. Here, I'll paste this in.
So the out must be in capital letters, I guess.
Look, I'll put it in the chat here. Pop.
Mm-hmm.
So this puts all those pins to out.
Okay.
Good to know.
And CT by dear byte equals 1 would do it. This. Pop.
Okay.
So now you should have your mode set to
Okay.
Now you can just click again the 3 and we should see other timing. That's slightly different. Well,
Oh, it's slightly. That's pretty slightly.
okay.
So you can use the REPL to toggle between by dear byte equals 0 and 1 and see the difference.
But it's not that. So I suspected at least a bit more, but
Yeah, it does look a bit.
yeah, but I think we need a higher temporal resolution there.
Yeah. I don't think we're going to get this on.
So you sample at 100 megahertz, right? So is there any a chance that you can sample with a much higher rate?
Yeah,
No.
that drop down. What happens? I've never tried. There's a drop down there at the bottom of the screen that's 100 megahertz, and it looks like you can change it.
125.
Yeah,
Okay.
I just don't know why. What the cost
It's not
is.
going to give us much, though, is it? Oh, I do see more points, though.
Yeah, but not so much. Yeah, we will tomorrow check with the gigahertz scope.
Oh, yeah, that would be nice.
And then I let you know, okay?
Yeah.
Because also the multiplier has a longer critical path.
Yeah.
And I want to demonstrate that in the lectures, that the people can really see this effect with real silicon.
Yeah.
Okay, thank you guys. I have to run now because I have the next meeting. But it was really nice to meet you and that you can now fill out the report so the circuit works. And it's not my first ASIC, but it's my first ASIC with open source tools. So thumbs up, guys. And I will send my regards also to the students. So
Yeah.
All the
Thanks so
best
much
to you.
for joining. Thanks for talking us through. And yeah, please share the results with your mega gigahertz scope. That'd be very interesting to see that. Yeah.
We will do that.
Yeah. Okay. Thanks again
Thank
for your
you.
time.
Have a nice evening. Bye-bye.
Cool.
Bye-bye.
Cheers.
All right. Thanks for the help with that, the REPL stuff, Pat. Okay, so we've got Daniel Robinson is ready to show something. So I'll add you back to the stage, Daniel.
Hi, so I'm back again, but this time it's not one of my projects. This one is Yuri's. It's his SiLife. So I think the SI is for silicon, but it's basically just a LED matrix, Conway's Game of Life implementation.
Yeah.
So, he couldn't make it to the stream, so he's just asking if somebody else could kind of show it. So I've got it set up. You can see it running there. This is at 10 megahertz. And that's one test pattern. He's got another test pattern that I can run, so I'm going to do that. I'm going to change it. This is his other test pattern. He's got an interactive mode as well, but I haven't tried that out yet, so I don't think I'll try to do it on stream. But
are these statically programmed, or they're actually playing the game of life and generating the from the starting point?
It is actually like playing the game of life, because you can set it to do whatever initial point, and it'll actually run through it. But I haven't set it up to be able to do that.
Nice. And you're driving this whole matrix with 5 wires?
Yeah, I think it's got like a serial interface.
Oh, okay.
Yeah.
That is cool.
But yeah, like I said, it's not my project, so I can't answer.
Yeah,
every
but Uri
question
asked. Yeah, so the reason Uri's not here is because he's just had a new child born on Monday. So congrats, Uri. And it's nice to see another child of your ASIC endeavors as well on the stream. So I just submitted a report saying that we tested it on the stream. So thanks very much, Daniel, for coming back on and showing this working.
Yep.
Yeah, and this was like a came in the PMod pack, did it?
Yeah, it did. Yep.
Cool. And have you tried all the other PMods out as well?
I haven't tried the Simon Says yet.
Okay.
I could pull it out. We could try it on stream.
I've got one here as well. So, but I think we probably we tried to use the rest of the time for some designs we've not tested yet.
Yep, sounds good. Right. I will head off. Thanks.
Okay, thanks, Daniel.
Cool. Thanks. Just got a message from Gerrit. I don't know if you saw that. Ready to show a project?
Yeah, Gerrit. Yeah, so Gerrit and Emilian are both ready to share things. So if you want to join with the invite link, I can post it again. And Leo's ready. Yeah, so just join anyone who wants to show something. Please just join using the link I just shared again in the chat, and then once you're here, I can just add you to the stage. There we go. Here's Gerrit, or is it Gerrit? Don't you hear you yet, Gerrit? But we see a little blinking LED.
Yeah.
Hello.
Oh,
can you hear me?
Yeah, I can hear you now. Yeah.
Okay. So my project was 3 different ring oscillators on the chip, and the idea is that they have different characteristics regarding temperature and voltage dependencies, and basically building a temperature sensor out of it. And I already have first results.
What's the number of your project?
Yeah.
Or the name?
Sorry?
What's the name or the number of your project?
TROS for temperature ring oscillator. So basically what we can do, we can take this very fancy cooling pack and make it maybe a little bit more less watery, and then put it on the chip. Wait a short moment. And then remove it again. And if we now look at this beautiful graph, let's give me a minute.
Oh, cool.
Oh, you have a graph.
How nice.
Yeah, of course. I like to play around with data.
Oh, that is cool.
And here at the end, we now see how the 3 different oscillators change the frequency when we touch the chip with the cooling.
What are the spikes? What are you measuring?
This is frequency. Maybe if I put a little bit more.
Just tell me the number of your product, your project. I can't find it.
Sorry, my microphone, my headphones are somehow very, very noisy. I cannot. Can you repeat?
The number of your project.
The name or the number?
Either.
It's TROS for temperature ring oscillator.
Oh, I got it.
I don't know by heart.
Okay, yeah, I got it. Select.
So what number is that, Matt?
398.
398. Because I'm currently set up to play with the core voltage, so I could do some testing on that front as well.
That would be really nice. Right now, I'm measuring the frequencies via the programmable IOs of the RP2040, but I also have a counter inside, which is transferring the data out via Manchester coding, but I have not yet tested or implemented that readout. So that would be the next step.
Okay. So for me to see this working, or me or Pat to have a look at this, we just need to have the scope attached to output pin 5, 6, or 7.
Exactly, and then you can see the frequency. And depending on some of the IOs, you can select different dividers.
Okay. Okay, yeah.
So what's the best approach to get precise results? No divider or more divider?
That's a good question. I would go. Depends how you measure. Primarily depends on how long you measure, how precise you are. So basically, for fast setup of the measurement, I would select the highest divider as I've selected right now, which would be 111. So 2 ones, because then the frequency is lower, and then basically the quantization from your oscilloscope or whatever you use to measure frequency is slower, and you get better results. And as it's a temperature sensor, it's not really fast. So right now I'm using the highest divider and also sum up above 4,000 rounds inside of the RP24, and then output that data, and then convert it back to what is the real frequency of the oscillators.
Wait, you're saying you're measuring the frequency with the RP?
Yeah, right now, yes.
Oh,
Because it's more handy than connecting an oscilloscope or log
yeah,
equalizer.
Yeah, that is great. And I'm just playing around with it on my waveforms scope here, and I can see this. Let me just put my screen back on. I can see I selected your design here.
Oh, you did the FFT?
I've got the FFT running, so I can see the ring oscillator out here, and I've got the FFT running, so I can see the base frequency.
So put your finger on the ASIC.
Yeah, I did, but I can't get them to move. So maybe
Really?
I need it. Well, it's going to be just a few degrees, isn't it? So if I put a hot air gun, maybe.
Oh, it's because it's really fast. You would need to set the divider pretty high, probably, to see.
Either that, or do like the averaging that you were talking about. But either way, that's awesome. Thanks very much for sharing your design.
Thank you for the opportunities.
Yeah. Anything else you want to share? End of stream. Dude.
Anyways, I will give it a spin. I won't play with the temperature, but once I'm done with this guy, the analog test, I'll just move the probes and do the same kind of looping over the core voltages.
I think it's looking like we're going to be we're not going to have to fill time with our own projects, because we've got enough people waiting who want to show stuff. So I'll bring Leo on next. Hi, Leo.
Perfect. Hey. Hi, Matt. Hi, Pat. How are you?
Yeah, good, thanks. And in case people don't know, Leo's the person who contributed the cool VGA P-mod that is being used by many designs now. And it's really awesome to have that kind of community contribution. So I really appreciate it. And it's great to see like so many people standardizing designs around it now, so that you can plug the one thing in and then try all these different designs out. So I guess you're going to show us some of that now, are you?
Yeah, exactly. So I'm showing you actually the design for which I designed the tiny VGA. So it's called One Sprite Pony, and a one-trick pony is someone or something that is good at doing exactly one thing, and that's what my design does. It can display one sprite, and basically the setup is just a demo board and a tiny VGA P-mod. And I created that because I didn't want to wire anything to another P-mod, and it's actually great to see that so many different designs now use the same pinout, so you can just select a design and you're ready to go. So let's try this. Plug it in, and yes, monitor is turning on. Yeah, there it is.
Ooh.
So yeah, the sprite itself is 12 by 12 pixels in size. And that's just because I couldn't get much more into just one tile. And the background is just procedurally generated. So with the position of the pixels and the current time value. And the thing is, this is just a demo setup. So if just anyone plugs this in so that they can actually see something nice. But the design actually has an SPI interface, so you can send a few commands to it, and then it will do some cool things. So let's try to connect.
I was expecting your one-trick pony to do just one sprite. This is much more.
It's a two-trick pony, right? So first, we can change the background mode. So this is just a plain color, but we can also use this one, for example.
Ooh.
I pretty like this one. It's actually pretty simple. You just XOR the coordinates of the pixel and just use this value as your color, and then it looks that nice. And then again, we
pretty
have
cool.
the
That previous background that you had.
yeah, it would be good for the demo competition, right?
Yeah, I was thinking of that.
Yeah,
You're already set.
yeah, true. But it has to do it by itself, right? So on its own. So diagonal bars and also horizontal bars. But we can also change the colors. So in this case, grayscale, also all of the reds and greens and blues that the tiny VGA can do, or we just set it back to these values. And we can also stop the sprite, and we can upload new sprite data. So that's why the sprite is so small, because it consists of flip-flops. And I think
So you have
Urish,
144 spots to put in?
yeah, sorry again, I didn't
Like
quite.
12 by 12, right? I have
Mhm.
this little array I can fill. Is that what you're saying?
Yeah, exactly. So you can set each pixel here, and it's configured as a shift register, because otherwise I couldn't get so many flip-flops in. And yeah, I think Urish, he also did a design, I think, for the VGA playground also, where there's just the tiny Tapeout logo. But in this case, it's a ROM, and it can be much bigger because a ROM is much more efficient, and it can also be optimized by the synthesis tools. So that's why. But here we can actually change that. And let's see if that works, because sometimes, yeah, like now, sometimes it glitches, because I was too cheap to add some additional logic, because otherwise I couldn't get this in. But let's just upload this again, and now we have a nice cocktail drink, or you can see it, right? Or a spiral, or yeah, a heart.
And can you make the
How are
heart
you-
bounce around?
Yeah, that's actually the next thing we
Yay!
can do. So this
Oh
is
wow,
now
it's got a
the
different movement now as well.
Yeah,
Yeah.
well, where's the spiral coming from?
That's yeah. Now it's glitching out a bit. This is the demo board, which is sending the coordinates. So it's yeah, you can just
It's
make
telling
it
it move
do
it to
whatever
here,
you
here,
want.
here, 1 point at a time.
Yeah, you just set the X and Y position, and it will move where you want it to
What's
have
the
it.
interface? How are you talking to it?
Just plain SPI,
So
and
it's
you
fine. Okay.
first shift in a command byte, and then you shift in your data. So there's a command byte for the X and Y position, and then yeah, you shift in the position. And for the sprite data, this is also a command byte, but for the sprite data, you can then shift in as long as many bits as you like, until you deselect the chip select then again. And so there's that. And at the time, I wasn't sure if this would be working, because this is using 40 megahertz as the main clock. And I wasn't sure, yeah, how well it would work, also with the output pins and so on. And so I added a mode where you can enable the 10 megahertz mode. So let's switch back to the diagonal bars, and let's enable this mode. And yeah, what we can see now, basically the background is a bit more fuzzy, so we can see the individual pixels here better. because now we're running at 10 megahertz, and it just takes more time until we set the next color. But the timing for the monitor is exactly the same, because the timing I've chosen, you can just reduce it, and it works exactly as well with 10 megahertz. So yeah, I have to say it was really easy to set this up, basically connect it and then select the design, and it is already working. And I've also used MicroPython for the first time. And Pat, you've done a great work on the SDK, so it was
Cool.
also
Thanks.
easy to
You use the ini file, right, to boot right into this project when you power up.
Which file? The ini file?
Well, how you just plugged it in and suddenly the VGA came on. Did you run a script, or did you how did you do that? Short version.
Basically, the design would boot on its own if I had set the frequency in the YAML file to the correct value, because I set 10 megahertz or 40 megahertz, and of course this isn't passed correctly. So I just changed the ini file to load my design and set the correct frequency.
Right.
But that's it. Yeah. And then for the to send the commands, at first I used a soft SPI implementation because unfortunately there's no hard SPI with the pins I'm using, but this is quite slow. And Mike Bell, he showed me his PO SPI implementation, and with this it works much faster. But of course, there still are the glitches. So for the next design, I would like to improve this, and also I'd like to use clock gating for the shift register, because I think here I could save some gates with the for each flip flop. I have a multiplexer basically, which takes quite a lot of area. So yeah, would be an improvement.
Do you know where the glitches are coming from? I mean, how's that happening?
Yeah, basically twofold. The sprite itself is just a shift register, and when I'm drawing the sprite, I have to shift out the bits, and I store this in a special row register, because each pixel is of course several actual pixels high. So I have this in my row register, and then I can draw it. But the thing is, if I write at the same time also to the sprite, then it also gets shifted, and things get out of sync. So this doesn't work well. For that, I tried to synchronize on the VSync signal, and it works mostly okay. Another issue that could be the case is when I shift in new positions, basically the new positions are shifted in. And when you shift in your new value, you have intermediate values, but these intermediate values are also used. And if the sprite is outside of the window area, then also bad things happen. So basically, I would add some safeguards for these edge cases.
Live and learn. Okay, thanks, Leo, for sharing your design. We've got Emilian and Milosch to invite on, so let's try and get them done in the next 10 minutes. So thanks again, Leo, and again for your contribution with the PMOD.
I'll be back in a second.
Okay, Emilian, are you ready to come on the stage?
Yeah,
looks like it.
Ready to demo, yeah.
Okay, so it looks like you've got an enormous scope there.
Yes, so I just have it hooked up to have the output 0 here, the input 0 into a signal generator. And sadly, I didn't make the deadline, but I'm testing the loopback project here. And this is 10 megahertz over here. And you can see everything's kind of nice and clean. And as we increase the frequency to 20 megahertz, 30, 40, 50, you notice that the level kind of decreases. But the input, I think, still works because the frequency is is 50 here, so it's catching everything, but the output buffers are not able to drive such a long line. And then actually, if I go all the way to 70 megahertz and 90, and I increase it all the way here, and I adjust the levels, it's still running through. So I think the input buffers go all the way to about 100 megahertz. So if anyone's looking into fast I/O, that seems like it would be doable. Whereas at past 100 megahertz, it gets kind of not so good. But up to 100, all good.
Great. And are you able to easily make a measurement on the latency of the rising edge to input to output?
Rise 0.1 nanosecond, but the amplitude is only like 150 millivolts.
Because we've measured for the loopback about a 20 nanosecond delay on the falling edge. So I'm just interested if that's something you can reproduce.
Right. For this, I haven't measured that. I've only measured kind of the edge, because actually I wanted to do USB or something like that, and that needs kind of low voltage but fast enough signal, and I more care about this edge. And here it's about 1 nanosecond for 100 millivolts of amplitude, roughly.
Okay. Great. Anything else you wanted to share?
No, that's it. Thank you for organizing everything. Now that we have analog, I'm super excited to also do an analog project. So
do you think you'll put something on Tiny Tapeout 8? Will you be ready?
Yeah, for sure. I want to restrict the kind of things that I want to do so that I make it to Tapeout. But yeah, I'm working on DRAM and fast I/O. Yeah, I have many ideas. So
excellent.
Yeah, definitely.
Yeah.
Thank you.
Okay. Thanks very much for coming on the stream and sharing this. Really good. Thank you. Okay. And lastly, we'll bring Milosch onto the stage. Hi, Milosch.
Hi, everybody. I hope you can hear me. Yes?
Yeah. So Milosch, you actually first submitted, was it on Tiny Tapeout 3?
2 and 3.
2 and 3. Yeah. And we had some sad times with one or the other because it didn't work for some reason.
Yeah, no.
But now you're back.
A mistake in my design, and yeah, finally 5 is working. I think I skipped 4. Okay, so here's my design. So the only thing you need to do is to connect to basically the UIO 0 and 1. The reason why it's 2 is to increase the volume. So it's basically differentially driven the piezo speaker, and it basically creates the Super Mario tune playback. So the only thing I need to do is to connect the REPL, enable. Yeah, you should hear it now. And it will infinitely play the Super Mario tune. And yeah, so let me turn it off again.
What clock speed do you need to run it?
It's 100 kilohertz.
Okay, yeah, it's already populated.
Yeah. So, I mean, fun fact is what the script actually does, it creates a Nokia ringtone into HDL design. So you have a Python script, and you can take whatever Nokia ringtone you have, and it creates basically the tone and so the frequency and duration database already calculated correctly for the 100 kilohertz. So you can make it do any sound you want as long as you either make or find the Nokia ringtone for it.
So you have like the equivalent of a MIDI player or something for Nokia ringtones, and in this file I say this tone for this long, and it just plays it. Is that right?
But yeah, but the interesting thing is it's hard coded. So once so it basically turns into HDL design, which you then compile into the floor plan. So and you can't change the artifact. So it's
right.
It's actual hard coded database of durations and frequencies. Yeah. So next step for me is probably to add multiple channels in parallel. So I'm not sure about sine waves because they don't sound great. So I'm actually happy about the square waves. But yeah, so maybe bumping up the complexity on that.
Are you going to stick with the Nokia idea or do like MIDI or something like that?
Yeah, I mean, I did a post yesterday because I had this idea how to re-engineer existing songs and detect the notes. So it's a bit vague, the idea, but what I would like to do is take an existing song and create a very simplified version of this and compile it again into HDR. So take over ringtone, you take actual sounds and create something that is very compact in the HDR.
Mm.
So including, let's say, the first handful of multiple frequencies that are used. So for example, if there is a harmonic at, let's say, 2 or 5 times the note, that would be automatically re-engineered from the actual song and turned into a simplified version of it. So yeah, but I mean, I still have a bit time left. So are you familiar with the Blackbird project? So there is basically like a research lady that created an amazing project which creates bird song from anything you want, which is essentially by taking, let's say, a song and reducing it to the bass frequency. So basically it sounds like a blackbird singing, but actually you can turn spoken voice into something that is actually blackbird speaking only in the bass frequency. Look it up. I think it's a set of Perl codes and it's super nice. But the concept is the same. You take complex sound, you turn it into something very simple like the bass frequency, and it sounds super interesting. I mean, you can't understand a word, but if you do subtitles, you see, oh, that's exactly that. There is, I think, even a podcast from like a major American podcaster, like a public broadcasting station about that. I posted in the chat in a second. So,
how are they doing it? They're just filtering out all the
it's
high
just signal
stuff.
processing.
Okay.
We've also got an uWooifier that was on Tiny Tapeout 5, where it's like a serial pass through, but as you type, it uWooifies whatever you type.
Yeah, I mean, so I created, just out of interest, a version where I extracted from, Rickroll, there's this song, and turned that into Blackbird. Let me see what I can find that, and I posted it in the chat. I have it somewhere.
Hey, Matt, what was the interface you were showing there on the waveforms?
That was the spectrogram.
It's pretty
So
neat.
you see the spectrogram, nice. Yeah.
So you can see the
yeah.
You can see the tune coming out.
Cool.
Yeah, you can see it changing on the FFT as well.
Yeah, I found it. Hang on a second. Here is
So square. Nice. Well, that was great.
Yeah, here is the link you can watch offline. So essentially,
how many tiles did it take? Sorry.
Huh?
Was that a 1 tile or 2 or?
Oh, this is only 25% of 1 tile.
The magic of hard coding. Wow.
Yeah, exactly. So I mean, it did the math. It ends up to be 0.4% of a square millimeter.
Not bad.
Awesome. Okay. So I'd like to draw this to a close now. So thanks very much, Milosch, for coming on the stream and demonstrating
for making this possible. I'm super excited about this. Thanks a lot.
Yeah, and I'm glad that you persisted. The first couple of design iterations didn't work,
exactly.
but you got it there in the end. Yeah.
Thanks a lot.
Cheers. Thank you.
Evening. Bye.
Thanks.
Yeah. So just an encouragement to anyone who's not tested their design yet. Please test your design and use the reporting system. It's hard to estimate how many designs have been tested, but it's very difficult to find designs that were manufactured on the Google MPWs where people have got the silicon back and they've tested it and they've published it. It's very, very small numbers. I think I've spoken to almost everyone that's done that. And with Tiny Tapeout, we're getting so much more concentration of projects, but we still need those designs tested. So I know that it's a long wait to get the boards back, but it's really very appreciated to make that final step and test your designs out. And we'll be building into the website soon the same reporting. So when you report with the Commander app, it will then also show up on the website. And then we'll also be able to do things like filtering by which designs have been tested. And the more people that test their designs, that's also great because we don't really know much about yield. We just assume that all the projects are working, but it will be interesting to see if many people test the same project. We'll also get a better idea of do things work across all the chips, because that's another thing that we're one of the few projects where we're pretty much using all the chips that we order from eFabless. And whereas most people, they get their 100 chips and they maybe only test like 5 or 10 chips. We're pretty much putting all of them into the hands of all of you who are contributing your designs. Gerrit says, can we override the initial test results? Yes. So I'll just show what that looks like quickly. So here, if I click report results for a design I've already reported, I get the feedback that I left last time, and then I can adjust it. So with that, thanks, Pat, for joining and helping out. Thanks, everyone who is watching. Super appreciate you spending your time and helping us with the Tiny Tapeout 5 Bringup party. And see you all on the Discord, and I hope you submit to Tiny Tapeout 8. Thanks for watching.
Thanks. Cheers.